Okay, today we're going to do the hardest thing with inequalities, which is graphing a system of inequalities. So first off, let's see what a system of inequalities look like. Generally speaking, you're going to have a squiggly bar like this, and you're going to have more than one thing listed here. So maybe you have y is less than 2x, and then maybe you have y is greater than negative 1/3 x plus 3. Okay, you can have more than two of these, but you'll have a system with at least two, because a system means more than one. So there could be three, there could be four, there could be five. Right now I'm going to show you with just two. So the first rule is you're going to graph each line. So you got to graph each line, and make sure you're graphing your lines correctly, because nothing matters afterwards if your lines are incorrect. So please make sure you graph each line correctly. Okay, as a matter of fact, I'm going to change this. I'm going to make this one less than or equal to. All right, so let's look at the first one. Y is less than or equal to 2x. Remember, if you don't see it here, there's a hidden number, and the hidden number is here at the end is plus 0. So since it's not listed there, the y-intercept is here at 0, 0. And it says we're going to start here. It says you're going to go up 2 over 1, because our slope is 2. So we're going to go up 2 over 1. And now I got to decide, is it solid or dashed? In this case, it's going to be solid, because the or equals 2. So I need a solid line through those 2 points. Okay? There's our first line. Now we're going to graph the second line. This is y equals negative 1/3 x plus 3. So I start at 3, which is right here. And it says I go down 1 over 3. So down 1 over 3 is right there. This is not an or t equals 2, so this is going to be a dashed line. And now I have both of these graphed, because the top one's graphed, the bottom one's graphed. Okay, now here's where we get to the test point. I need to decide where to shade, and I have up to 4 areas that I could potentially shade. There's this area over here that's below this line and to the left of this line. There's the area up here that's above this line to the left of this line. And we got the 2 areas over here. So we don't care about the original coordinate grid. We care about where our lines intersect. There are 4 areas: to the bottom left, to the top over here, to the top right, and the bottom right. And we got to figure out which of those areas to shade. And what we're going to do is we're going to use a test point, and we're going to have to decide on both of them which side to shade. And where both are shaded, that's where our answer is going to be. So we're going to use a couple of colors right now so you can see it easily. So I'm going to do green, and we're going to do this for a test point for this first one. Now, generally I like using 0, 0, but I can't use 0, 0 in this case, because 0, 0 is on this line. So I'm going to pick this one right here, which is 1, 0. So we're going to use 1, 0. So x is 1, y is 0. Okay, so using this, we get y was 0, so 0 less than or equal to 2 times 1. Well, 0 less than or equal to 2 times 1. 2 times 1 is 2. Is 0 less than 2? This is true. 0 is indeed less than 2. So we need to shade the side where 1, 0 is. So we're going to shade to the right of this line. And now we're going to do the same thing with the other one. So in this case, 0, 0 is available to us, because I'm looking at the dashed line right here. So we're going to use 0, 0 here. So we got 0 is greater than negative 1/3 times 0 plus 3. And the nice thing about 0 is that negative 1/3 just went away. So we got negative 1/3 times 0 is simply 0. 0 plus 3 is 3. So the question is 0 bigger than 3? This is, of course, false. 0 is not bigger than 3. So I'm not going to shade the bottom side. We're going to shade the other side away from 0, 0, which is up here. Now, if you look what happened, there is one section where we have both the green and the yellow, and that is our solution. So I'm going to take our blue color out, and the shaded area that we need to see, this is our solution, is here in blue. So the blue, and only the blue, is a solution. Okay? So the solution is going to be where both are true. Now, you could take a test point in each of the 4 quadrants and check them in both and see which one's true. That's also fine. But I was just showing you this way because it's a little bit more colorful. So our answer is, the only solution is this area up here. Anything to the right of this line and at the same time above our dash line is our solution set. Okay, so this is for 2, but we could do it for more than 2. So let me show you a case when you have more than 2. Gotta get a new piece of paper out here. let's say that we have a solution set that looks like this. I'm going to go back to black. Say we have x is greater than 1, x is less than 5, x is, let's make it a y. Eraser. There we go. So we got y is less than 2x plus 3, and yeah, we'll just keep those 3. Okay, so we're going to have those 3. So first thing I need to do is get a coordinate grid going. So here's my coordinate grid, and I have to graph these lines. First one is x equals 1. Well, x equals 1 is you go find 1 on the x-axis. It's right here. And since it's just equal to, it's going to be a vertical line straight up and down. But remember, it is not or equal to, so it's going to be a dashed vertical line. So we go over here, and we're going to make a dashed vertical line straight up and down at x equals 1. And now we're going to do the second one. Let's go ahead and change it. We're going to make this an or equals to. So we get x is less than or equal to 5, so I go find 5. 1, 2, 3, 4, 5. So here's 5. And because I do have the or equals to part, we're going to make it solid, so I have a solid line going right here through 5. The next thing I got is y is less than 2x plus 3. So this is we find 3 on the y-intercept. So 1, 2, 3. So there's 3 on the y-intercept. It says go up 2 and over 1, which is right there. Okay? And then because there's no equals to, this is going to be, again, a dashed line through those points. Okay? And if you notice, we end up with 6 sections to look at. So let me do those in red. We could be in this section. We could be in this section. This is second section. Third section is over here, and it's going off the thing, so to the right. There's a fourth section down here. There's a fifth section right through here. Remember, the original axis don't count. And then there's a sixth section over here, all of this. Okay? So we got to figure out which of these sections we're going to shade. And it has to be true for all 3 of these. So you could shade each one, or you could check in each case. So first one I'm going to look at is this. It says x is greater than 1. Well, if I'm looking at x is greater than 1, the bigger numbers are to the right. So I know that 2, 0 is going to be a solution because when x is 2, it's bigger than 1. So anything to the left is gone. So we're going to get rid of all of this over here. None of this exists. Okay? So we know that somewhere in either 2, 3, 5, or 6 is going to be the answer because we know that none of this exists because x has to be bigger than 1. And then we can look at this one. It says x is less than 5. So if this is 5 and I need numbers less than, anything bigger than 5 is also not existing, so none of this exists. So now we're down to just 2 solutions. It's either going to be 2 or it's going to be 5. And this last one's going to tell us which is true because right now 2 and 5 are both at the same time bigger than 1 and less than 5. These two areas right here. So we need a test point. It doesn't matter what you pick. Let's go ahead and use this test point because it's a 0. So we got 1, 2. So this is going to be the point 2, 0. So let's go ahead and plug 2, 0 in here. So y is 0. And we got 2 times 2 plus 3. 2 times 2 is 4. 4 plus 3 is 7. So the question is 0 less than 7. And yes, of course, it's less than 7. 0 is indeed less than 7. So this test point is a solution. It's a solution here. If I use 2, 0, this says 2 is less than or equal to 5. This is also true. And if we use it here, we get 2 is greater than 1. This is also true. So this section right here, bound by the dashed line at the top, the dashed line to the bottom, and the solid line to the right, excuse me, to the left, the dashed line. This section right here, this is our solution section. Only this section here. The other 5 solution areas are not solutions, so just this one right here. Okay, and this does go off forever this direction, but it's just off our graph. Okay, so if you have 4, you could keep going, and you just got to all that happens is you keep getting more and more sections that you got to figure out which is the section where it is true for every single one of these. All right, if you got questions, you know how to ask.